American Sign Language, ASL, is the visual language used by deaf people in the US for communication. It's the third most used language in the US, with about 500,000 signers. ASL is expressed by movements of the hands and face, called signs and non-manual markers. Deaf people today are having many communication issues, thus they receive discrimination. So we want to use AI to help the deaf community. Specifically, we target finger spelling today. If you want to learn more about full ASL sign detection, check out this article that talks about using 3D spatial temporal CNNs. So what is finger spelling? Finger spelling is a way of spelling words with letters using the hand. All 26 letters of the alphabet have a hand shape, like ABC all the way to XYZ. So can't we train a 2D CNN that recognizes these hand shapes for translation? That's exactly what we did. Before that, we need to understand what CNNs are first. They are deep learning models for images. We train a CNN with input images, improve it with known outputs, and employ it in the real world. For CNNs, the key is that the CNN uses kernels to perform convolution and pooling, which is compressing, to successfully decrease the image maps to achieve a flattened layer. This allows CNNs to work with images rather than simple data values. The input is an image, and kernels are matrices that move all over the image to perform element-wise multiplication with the RGB values of the image. The values in the kernels are specially designed so that once multiplication is done, certain features are extracted like edges, lines, curves, etc. in the image. Next, pooling techniques help to decrease the size of the image maps and flatten them to familiar layers of neurons. And finally, the output is produced. Now let's get into our solution to the problem. We used a random forest classifier. The random forest classifier is a type of machine learning model used to make decisions, like identifying or classifying objects. It works by creating a collection of decision trees. Each tree is trained on a slightly different part of the training data, and when it's time to make a prediction, all the trees vote on the answer. The final result is based on the majority vote, so it's kind of like democracy. Random forests add randomness in two ways. First, by using different samples of the data to train each tree, and second, by randomly picking only some characteristics of the data to make decisions. This randomness helps prevent the model from becoming too focused on specific patterns in the training data, which might not generalize well to new data, so it prevents overfitting. Random forests are very effective because they combine the strengths of many decision trees, which makes their predictions more accurate and less affected by noise or errors in the data. They work well when data has many features or when the patterns are complicated and not simple to detect. Perfect for ASL handshapes. Random forests are also good at handling wrong data or unusual examples, because individual trees might make mistakes, but the group decision evens those incorrect ones out, and therefore it's actually less likely to make mistakes. This makes the random forest classifier a strong and reliable choice for tasks like classifying ASL handshapes, where small details and differences matter. This ASL handshape and classification process involves two main stages: detecting hand positions using a pre-trained model, and classifying handshapes with a random forest classifier. Here's a detailed explanation. First, we use MediaPipe's Hands module to detect hands in real time. The program captures live video feed using OpenCV, and MediaPipe's Hands module, essentially a CNN at its core, processes the frame and locates 21 hand landmarks if a hand is present. The next step is to prepare data for classification. The X and Y coordinates of all 21 hand landmarks are extracted, normalized, and put into one list of 42 values. This list is the input for the random forest classification model. Finally, a random forest model is used to classify the hand shape into one of 26 ASL hand shapes in fingerspelling based on live video.